This is a talk about digitally driven manufacturing, which is something we've spent the last roughly 7 years at Buttonsmith, coming up on 8, working on. I need to open with a disclosure and maybe a disclaimer, because we're in the middle of a Reg CF public offering. So there are a lot of things I'm going to say that are opinions of mine or are forward-looking statements. And of course, some are going to turn out to be wrong, and others will be superseded or refined, and some of them may not happen at all. So, there we are with the qualifiers. And all of the people, I can see at least know that, but who knows who will watch this thing after the fact. So, being as how this is a university class, we have to start with a multiple guess question. So what is a buttonsmith? And the possibilities here are someone who makes buttons, a name you will keep until your current race is done, a software company that is automating digital production, or a light manufacturer, which, by the way, is what Crunchbase and PitchBook thinks the answer is. We are, in fact, a software company that is automating digital production. We set up a production facility because if you want to do that successfully, you have to know how it actually works. And that prototype manufacturing facility has been paying for our software team. So I suppose we're doing something vaguely right. And it's amusing because we present to the world as a manufacturer, but in fact, we're a company run by software people. So this is not really a tech talk in the tradition of EE380, right? I mean, EE380 is about processor architecture and microkernels and internet worms and modular assembly robotics and cool technical stuff. Dennis, that last one is a future promise for you. And these are all things where we're talking about activities where the gross margins in these activities in the mature companies run about 75 to 85% as the gross margins, right? This is a talk about reimagining manufacturing. And so I'm going to talk about what are the assumptions around the problem that are getting in the way, what are the possible solutions, what are the economic and commercial systems and environment look like. And manufacturing is an activity where the gross margins today are in the 7% range. And step back and think about yourself as an investor and ask yourself, if you get to invest in something with a 7% return or something with an 85% return, which way are you likely to go? And while I gather that Forest Basket may be doing some investment in this area, by and large, if VCs tell you that there's investment going into manufacturing, first, it's not coming from them, and second, it's probably not happening at all because economically it doesn't make a lot of sense. Where we're trying to move this needle, and where we're trying to get it to, and I think we have a reasonable chance, is to get manufacturing to something with gross margins in the 30% range, while reducing consumer prices on the resulting products by potentially a factor of 5, and I'll get back to how we do that, and also providing higher revenue to the producer, because if the customers are buying products that they already know they want, they actually will pay more for those products. It is very much not in the incremental, agile methods sort of approach. There's a lot that has to be built to make this work. And we have in fact built it one step at a time, working from the customer back. But if you start from manually set type and you take an incremental approach, right, what you end up with is a Heidelberg
windmill letterpress is the culmination of over 100 years of refinement and development by Heidelberg. It is probably one of the fastest platen presses ever produced for letterpress printing. While many other platen presses feed the paper with the same motion that it is delivered, the windmill had 2 arms so that one could be feeding the paper and the other delivering paper, thus making the press nearly twice as fast as other platen presses.
So as it happens, we actually have 3 of these machines. We've taken them off of our floor because they're far too dangerous to operate. But if you're looking for a mental pigeonhole to put the Heidelberg in, right, this is what a Xerox press looks like in 1938. It's capable of doing 4,000 to 5,000 impressions an hour, depending on which version of this you're doing. The catch is all of those things have to be printed with the same thing, right? Because you're putting a plate in the machine and it's a letterpress printer. It's a plate printer. Depending on which version you're looking at a 7-ton press, right? Running at 4,000 operations an hour. Do not put your hands near there. And that's why we're not running them. Of course, that kind of incremental approach, right, will not get you to something like an HP Indigo, which is the thing at the bottom right. I mean, to get to an HP Indigo, you actually have to reimagine what printing is about, what composition is about. You need some form of computer in this picture. You need some form of typesetting in this picture in the software sense, right? There's a whole ecosystem that has to be built to make a machine like an Indigo make any sense, or a Xerox press, or take your pick. When the Indigo just happens to be the latest, shiniest toy in this particular space. And what we're doing is very definitely in the disruptive camp. We've been told by approximately everybody in the venture investment world up here in Seattle that we should, find a more contained problem. And the problem with hard things is they're hard. The good news is we seem to be succeeding at it. So why should we care about fixing manufacturing? And the part of the answer is it's a strategic issue, right? One of the things that I think we've learned in the last two and a half years is that there's no meaningful economic security without a viable manufacturing sector. There's no meaningful national security without a viable manufacturing sector, right? We went into a world where we needed masks. We largely depended on China to produce them, and what we got was counterfeits, right? And some of that was just the usual thing from Chinese producers, cutting corners and shaving the edges, but some of it wasn't, right? We also saw active marketing attacks on US sellers who were selling legitimate masks, right? This was not pretty. And that's not the kind of dependency structure we want to be in when we're looking at a national crisis. There's nothing new about this. We've been talking about this in chip fabrication for at least 2 decades that I know about, probably longer. Having dependencies on people whose interests are not necessarily aligned with yours is problematic. And the manufacturing sector is one of the big places where we have an issue. But another reason is, right, we have a problem. If you look at growth in the US manufacturing sector, you discover that it's 2% a year, and that number goes back pretty consistently to 1970, which is when cargo containers come into the picture, right? And with the arrival of cargo containers, what you start seeing in manufacturing is some class of products starts struggling, right? It falls out of US production. Its production moves to China where labor costs are lower. The reason we're sustaining this 2% growth is that other products come into the fold and start getting manufactured, right? And then progressively they start to fall out of the system. So this is not a story about the success of manufacturing. This is a story about kind of eating our seed corn. And this steady state number, I mean, this isn't growth in any meaningful sense of the term. And the reason that matters is the story in China looks very different. Right? They've been seeing 13.6% growth annually since 2010 or 2011, depending on where you want to draw the line. And that means they're growing 6 times faster than we are, and that's not a sustainable position for the United States. It's not a sustainable position for a lot of other countries. We just happen to be telling a US story this week. But as if that wasn't enough, in the last 10 years, we've lost 30% of the headcount in US manufacturing. Right? That's not a manufacturing problem. Right? That's a structure of society problem. Right? We're at the point where the disparity of wealth in the United States, at least historically, is a danger signal for revolution. And I'm not suggesting that we're going to have a revolution this week or next week. I don't know if we're going to have a revolution at all. But it's not at all ambiguous that we have an enormous part of the problem for the population that's tremendously disaffected and feeling disenfranchised. And I think we proved that in January. We're in a risky place. And part of it is that in losing manufacturing, we undermine the middle class. And the middle class is necessary to the functioning of our society. And by the way, the employment levels that we're seeing in manufacturing right now have not been seen in manufacturing since October of 1945. This is kind of crazy. So I think that there is a societal issue here of how do we restore a balanced society. And I think this is not all of the problem by any means, not all of the solution by any means, but it's part of what we need to do. All right. There's an existential issue here, right? Mass production means that you're producing products long before you have a customer and long before you can really assess what the customers in a bulk sense actually want. And the output of that process means that 30% of mass-produced consumer products never find a customer, right? They get destroyed, they get given away, they end up in landfills. In the fashion industry, it's worse. The number there is worse. The number there is closer to 50%. And in the high fashion industry, it can be almost 90%. And the reason for this basically is that there's no customer at the time the product is being made. You don't actually know what the customer wants yet. And we as purchasers are paying for all of this waste, right? It's not like these products that get thrown away disappear. The cost of them gets baked into the products that do get sold. It's an existential issue in a different sense, right? China produces more greenhouse gases than all of the OECD and EU countries combined. And more than 60% of that is directly or indirectly attributable to manufacturing. It doesn't seem to me that relying on China to do our manufacturing is necessarily a place that we want to be if we want to be able to breathe 10 years from now. We got stuck here in 1970, right? We started this process of mass production circa 1910, 1920, depending on who you want to give credit to. And we've stuck with what's been succeeding. But in 1970, it stopped succeeding very subtly, very slowly, right? But that's when the dominoes start falling on mass production. And we have been banging our head against the same wall, looking for different results for the last 50 years. And that's not a good experiment. At a certain point, you have to realize the experiment is failing. And part of what's going on is we have assumptions about what's feasible in manufacturing that no longer hold because the tools that we have to do manufacturing with have changed. And this is the classic what you know that ain't so because the conditions have changed. Of course, the things that you don't know are good for plenty of mistakes too. So we got to watch out for these. It's always cheaper to learn from other people's mistakes if you have the opportunity to do that. So here's what we assume in most of the manufacturing world is possible, right? At one extreme, we have what might be characterized as artisan production, right? We have people who can do lots and lots of different things, right? But they're not doing very many of them, right? So a high mix, low volume sort of environment. And that ranges from your local bakery to anybody who's producing anything by hand or anybody who's producing something custom one at a time that's involved to produce and is not being done digitally. At the other extreme of the spectrum, right, we have classical mass production, right, which we've been doing for more than 100 years, right? You can get as many as you want so long as they're black. Nowadays, we can even give you other colors. That was an interesting refinement along the way. And we've made some move in the lean production world to improving our ability to do mixes in this process, along with a lot of other improvements, right? This is the Toyota production system, right? This is how Toyota beat the American car industry. I'm going to keep out of the yellow box. It was here mostly for my amusement because it was late when I was doing the slides, but it's a little off topic for manufacturing. Here's what we can do today, right? With digital manufacturing tools, right, we don't have to do the same item at each cycle as we go through the production process. And that means we have a whole portfolio of options ranging from doing mass production, right, to doing one-off production. All of that stuff is on the table, and that gives us tremendous options for how we approach production. I'll get into why that's possible. So when we talk about digitally driven production, right, what I'm thinking about when I talk about this is a production model where we're going to make what the customer actually wants in the quantity that they want, right? Don't tell me I've gone to BIC and I want printed pens, but I can only buy them by the 100, right? Without specialized customer expertise, right? You see a lot of discussions in this space that start with send me a CAD file, and I'll come back to why that's kind of ridiculous. But whether it's ridiculous or not, most customers don't know how to generate CAD files. This is not a business model in a scalable sense. We want to do this on demand, right? I don't want to make anything until the customer has already paid for it and very clearly told me that they want it by paying for it. Otherwise, I'm taking a production risk, right? And that's actually what we're doing with mass production, and we're doing it at a grand scale. We want to produce this at a lower price, and I'll talk about how we think we can get there. We want to do it at higher margins, and that's about giving the customer what they actually wanted and knowing that we did so, and frankly, not flooding the market with the same product over and over again. The goal is to do it locally because we want to reduce transportation steps, and I'll get back to that. And hopefully we can do all of this without destroying the planet, and we at least actually believe that's possible. It's going to involve major changes. This is not easy. why is this conceptually hard to do? Why, if I'm a manufacturer, is it almost impossible for me to get from where I'm standing to doing this type of what we're describing as digitally driven production? So first, we're not just talking about additive or subtractive manufacturing here, right? Jeff Wilke is pumping enormous amounts of money into that, apparently doing great work. And 3D printers and CNC milling and things like that are definitely a piece of this problem, right? But these are, machines that do a particular function in a larger ecosystem that has to be connected, right? If we're actually going to do single piece production, it involves changes in how we think about product design, because we need to be able to do variations, and those variations need to be part of the design process up front. They can't be arbitrary variations if we're going to do them successfully. We need to think about listings, and I'll come to that in a second, right? We need to think about how sales work. This is mostly a direct to customer or direct to business sort of a production strategy, right? That changes our distribution structures, and that's going to take us back to transportation. It's going to change the way we order things, because if you walk into a local print shop and say, I want to print a wedding invitation, 30% of the labor cost for the printer goes into extracting from your head that thing that you're not quite able to describe, that is the thing you want them to produce for you, right? That's an enormous cost if you're only going to make one. We need a better way to think about that. We need to change the production management so that as we're making those one and they're going across the floor, when they come at the end of the production floor, we know which one's going to who. And if one manages to drop somewhere in the process, we know which one has to be recovered and who it's going to after it's recovered. And of course, the fulfillment strategy changes, because instead of sending a truck with 60 pallets of one thing, I'm sending a truck of FedEx envelopes, right? Each of which is going to a different address. And that changes how I think about doing fulfillment, changes the cost of fulfillment. None of these things that I'm describing, with the possible exception of the production itself, although I would say mostly not for single piece production, none of these things are core competencies for manufacturers, right? This can't happen by magic in the existing manufacturing ecosystem. And for the most part, and there certainly are some exceptions, manufacturers in the United States and in most of the world have relatively little capital. They're operating on very low margins. They're largely debt funded, right? They're borrowing in order to buy parts to produce products. They don't have the wherewithal to do this without some outside help, which is why Buttonsmith exists. We're trying to put together the software infrastructure to make this sort of thing possible. Flexibility is not something that I think of as one of the founding principles of manufacturing today, right? In software, we totally take it for granted that we're going to build general purpose software. It's going to have a whole bunch of applications, and we're going to invent more as we go, largely without changing the software, right? Then the software will evolve and it will chase us into these new applications. But fundamentally, we don't think about building software outside of the embedded space for some narrowly defined single purpose. That's totally how we think about doing manufacturing equipment. And there are companies out there that are starting to poke at this. Bright Machines has done some interesting work, although I think there's much to be learned from what they did. And then after you get through all of that, right, there's this belief that China has already won. So what's the point? And so if we're going to actually move manufacturing into a sustainable value proposition that can be executed in the United States, and if we think that China has won the game already, then what we got to do is change the game. And the beautiful thing about low volume production is you can't do it cost effectively from the other side of the ocean, because you can't take 5 things and shove them in a cargo container and sell them to me at any rational price. It doesn't work. And there's no way that's ever going to be possible from Beijing, especially now that we've stopped subsidizing China Post. But all of this requires a very different way of thinking about the problem. And the very hardest part of this, as in any major change, lies in mindset, right? How do I think about this as an end-to-end problem? There's this ubiquitous issue that manufacturers will buy some big piece of equipment that gets sold on it. Maybe it's a great piece of equipment. Maybe it does whatever it does 10 times faster than the previous piece of equipment. But that's only helpful if the rest of the process after that machine is prepared to accept input 10 times faster. If it's not, all you've bought is a really sexy machine that's not actually moving the ball forward for you, because you can only go as fast as the steps that come after that machine. And you see this happening all the time. Right? there's a mindset that I can't do it, right? I don't have the cash flow. I don't have the free cash to invest. And I don't understand how e-commerce works, right? I don't understand customers because I don't talk to them, right? There's a view that it's always been this way and it doesn't have to change, right? We see that in everything. There's a need to talk to end customers. Right? How many manufacturers actually speak directly to customers? And the answer is almost none of them, right? Maybe they talk to Walmart, but Walmart isn't the end customer for the product. And for Walmart, we could name lots of potential companies, right? But there's almost no feedback loop from the end customer back to the manufacturer other than how many of them actually got sold, right? But that's not very detailed information. And the people in the middle, the distributors, the middlemen in the wholesaling world, right? They think the customers are their property. They're not eager to put the manufacturer in touch with the customers. They want to be an information bottleneck, right? Because this is about lock-in. We need to think about turnaround times differently. If you go to a large promotional producer with a large order, they're going to say, you'll have your 1,500 lanyards for the next Usenix conference in 6 weeks, 8 weeks, something like this, right? That needs to be done tomorrow, especially if we're talking about low quantities, right? People aren't going to come and say, I'm going to order my lanyard or my hat or whatever it is that I'm ordering, and it's okay if it gets to me in 6 weeks. 6 weeks is forever. Amazon has invested millions of dollars in teaching people something they already basically had, which was a desire for instant satisfaction. And they've done that very, very effectively. That's actually an advantage if we look at it the right way, but it's a challenge. It requires thinking differently. And the distribution model changes entirely, because if I'm producing on demand, I don't need distributors for finished goods, right? That's a big red flag because my distributors aren't going to like that. Right now, if I'm a mass producer, right, I design a product or I work with somebody to get a product designed. And the next step is I build a whole bunch of them and I push them into the market and I hope like hell that they sell. And sometimes they don't, right? We have to work from the customer back, right? We have to ask, what does the customer actually want? How are we going to produce that? As opposed to, we've produced this thing, how are we going to convince the customer to buy it, right? This is a total 180 on how to think about sales. And that's what I mean by this pull, not push notion. I'm borrowing lean terminology here, right? We also need to think about how production flow works. Right now, I build a huge pile of stuff and then I move it on to the next station and it tries to consume this huge pile of stuff. That's crazy, right? I built a pile, I took the pile apart. That was totally wasted effort. What I wanted was a floor where everything flowed smoothly. And as each unit came out of a stage, it's ready to go into the next stage. The next stage is ready to take it. If I've got a pile accumulating somewhere, I haven't designed my floor correctly, right? And that's not the way manufacturers mostly think about this problem. And I'm making very general statements about manufacturers. There are definitely exceptions to these statements. I'm sort of speaking broadly about how people in this world think. We think about finished inventory in many manufacturing contexts as an asset, right? We want to send stuff to distributors and the distributors buffer us from the changes in demand variations in our end customers, right? And we think that's good. But what that's actually is an exposure, because every one of those things sitting in distributor inventory is at risk of never being sold, right? I've made it ahead of sales. And that's not a good model. And if you've looked at the sort of classroom studies that are done at the major business schools, one of the fun games that you'll see is something called the beer game. And it's how you go out of business as a beer producer by committing the sin of producing a new successful craft beer. And you go out of business because the distribution hierarchy creates enough latency that by the time you realize people are running with your beer and drinking it like crazy and taking off and you need to build more, right? By the time you find that out, you have to stand up another production facility. And by the time you get the production facility done, the customers have moved on to the next beer and now you can't pay for it. So this kind of buffering is actually an exposure. It's not an asset. This isn't just an issue for the manufacturer from a standpoint of product risk. It's also an issue from a standpoint of lending. If you go to a lender and you want working capital, one of the things they're going to look to collateralize it on is your inventory. But your inventory is a risk. That's the last thing you want to collateralize on. Mindset. To an incumbent, these issues are well beyond terrifying, right? They mean totally rethinking the business that you're in, and that's always hard. as a producer, if you decide you want to do this, right, you don't get to shut down any of what you're doing today and say, I'm going to take a month off and I'm going to figure out how to deploy this stuff, which, by the way, I'm not going to get right the first time because there's a learning curve, right? And I'm going to switch gears, right? You don't actually get to do that, right? You have to keep making money while you're doing this, which means you're in two camps in your head at once. We're in the middle of actually moving our production floor from one location to another. We're not changing how we're doing things, but we don't get to shut down production really to do it. Merely moving stuff in this way is a nightmare. If I were trying to change our production strategy at the same time, I'm not sure what I would be turning to for solace, but I'm sure my wife wouldn't approve. And if you do this, if you admit that you're doing this, that you're starting to think about selling things directly to customers, what happens is in many sectors, your distributors blackball you, right? And then your revenue disappears, and then you don't have any money to pay for all this. This is a real challenge, right? You're kind of a pig in a poke if you want to do this, and it's hard, but it's not optional because there's no meaningful market for hand type today, right? We have to move on. And moving to the Heidelberg windmill press, which in 1938 was miraculous, is not miraculous in 2020. Right? There's also no market for buggy whips. Well, okay, there is, but it's not the market that we cared about. There are technical challenges in this process, right? As if the concept issues weren't enough. There are a whole horde of technical issues, right? We need to reduce labor per unit. And we'd like to apply automation to that. But the state of the world in robotics is about where we were when Bill did BASIC for the MITS Altair 8800, right? That's where we are. We don't have huge piles of software infrastructure. We don't have notions of modularity in automation by and large. And there's a hardware issue and there's a software issue, and then there's a process issue. And all of those things have to modularize in compatible ways for this to work. In many cases, we don't have good material handling solutions. One of the reasons that we don't have fully automated cut and sew is it turns out that handling of fabric is really hard. If you talk to people doing robotics, right, notice that all of the things they want to talk about are rigid. Even just putting tape on something, right? If it's not a rigid material, find a tape machine that can apply a strip of tape to that product, right? And there is one, right? It's done with a clamp and a robot arm, but it's not a traditional taping machine. We can't deal with things that are shiny. That tends to break a lot of the vision tools that we would like to use in robotics. We have similar issues with things that are clear. So there's this whole class of things that are kind of, we haven't gotten to yet, is the charitable way to put it. Some of which are very, very, very high value items, right? Being able to change the way garments are built, there's a lot of money there, but it's a hard problem. In the midst of all of that, the assembly issue tends to get ignored. There are parts of assembly that we don't actually know how to automate. For starters, almost anything involving sewing. That becomes the bottleneck, right? And people forget, as they're working their way through this big complex problem, that the labor time in assembly is actually the big cost in all of this. Maybe labor and shipping if you're really shipping one at a time. Right? But those are the two costs. Nothing else actually really matters in any of this. It's not very big in your cost of goods. How do I approach production thinking about it as if I get a 10,000 unit order, I'm going to produce 10,000 single items and then I'm going to put them in the same box instead of I'm going to do 10,000 copies of something. And the reason I want to think about it that way is I want the flexibility not to care if it's 10,000 ones or 1,000 ones or 100 ones. I don't want to change my process to do that. And I also don't want to have to get into a job shop scheduling problem to navigate around this 10,000 piece order. Right? If I get a single piece order in the middle of that, it's not clear that I want to run to the end of the 10,000 piece order before I go deal with the single piece order. And there's no reason why I shouldn't be able to sort of Cuisinart these things together if that's advantageous in serving my customers. That's a change in the way we think about production because we get to divide jobs. And that's something we don't get to do in a mass production floor today, for the most part. How do we do product designs that are parameterizable? How do we make it possible for customers to choose variations on what they want made in a way that's approachable from a user experience perspective? And then when it's all done, can be turned directly into something where I can send it to the machine that's actually going to do the production, and I'm sending it digitally in production ready form, right? There's a whole set of technology issues getting from the listing to the user going through the customization experience to getting this thing produced. And if what you're trying to do is get an image on a t-shirt, there are lots and lots of pieces of software out there that will do that. But that turns out to be, relative to the rest of the space, kind of an embarrassingly easy problem, right? If you try to do this for any more general customization, you'll find that that's quite hard. And I should be clear that we're not necessarily just talking about, I'm a customer and I want my slogan or my name on my product, right? We could also be talking about a small retailer who wants branding on things for their 4 or 5 stores, right? Or we could be talking about things that aren't in any way modified for the customer. We can do all of those things with this kind of technology. How do we do listings at scale? That one turns out to be brutal, and I'm going to come back to that one in a minute. We have equipment that, first, equipment that exists, right, is all more and more intended to serve, well, it's mostly intended to serve the people who want to do thousands of things. If you want to buy a wide format printer to produce 4,000 miles of wallpaper, EFI has the product for you, right? If you need 6 inches of print because you're doing one lanyard, it is totally not the right solution for you, right? So how do we get that solution? Right? How do we get equipment that serves this model instead of the bolt model, but also doesn't give up the bolt model? How do we get the software to do it? The integrators are focused on the wrong problem. We're talking to robotics integrators at the moment, and one of the things we've realized is by the time we're done getting it into their heads that we're trying to automate single piece production, and we could have done the integration ourselves, which is what we're going to end up doing. And all of this stuff is going on in silos, right? People have this idea that they're focused on one machine, right? ESCO has some fantastic printing and cutting technology, and their notion is that if there's a robot involved, it's going to feed material onto their machine, and they're going to run the print on their machine, and they're going to palletize the result, gather it up onto a pallet, and then you're going to take the pallet and move it to the next cell. And for ESCO, we could drop 15 different printers into that statement, right? But that's actually not what we want. What we want is flow, right? We want that thing to come off of that printer and move directly into the next step of production. Putting it into a pallet is pure waste. And that's not the mindset coming from the vendors. And if you try to talk to them about getting access to the information you need in order to do that sort of integration, it's possible, but it's definitely an interesting exercise. There's a trust building process that has to happen because they view that stuff as tightly held, partly because it's an opportunity for the customer to really have a bad outcome with their equipment. And they're concerned about that. And they're right to be concerned. And then, down at the nuts and bolts layer, we have, 10 different major vendors producing robots that you can buy here in the States at this sort of small production tier. Every one of which has a different operating model and a different programming language from the last one. Some of them are more capable than others. Some of them forgot little things like recursion or subroutines in the way that we think of it now. And sometimes the robot you want isn't from the same vendor you purchased from last time. And even if it were, that robot now has to operate in an environment where it's taking something from one machine, it's doing some robotic function, it's putting the result into some next stage process. It's not just about programming the robot, it's about having the robot engage with the machines around it. We don't have a good platform to stand on to do this kind of integration. The work on robot operating system looks interesting, but it's far from there yet. And then the process challenges. One of the things that's just brutal about doing single piece production, if you watch a manufacturing floor, you will see a whole bunch of scenarios where somebody is walking around with a bin or they're pushing a cart, and in this bin there are 100 or 1,000 items. And the 5 minutes that person takes walking across the floor, divided out over the 1,000 items, sure, you'd like to get rid of it, but it's not your biggest problem, mostly. That labor, that 5 minutes is by the time you're done loading all the cost onto it, is surprisingly expensive. But if it's a large number of items, you can put that fairly down your priorities for cost reduction. That is just not true if that person's carrying one thing in the bin. We're well past OCD in our process design and our floor design. If I can take 2 seconds out of the walking around phase of a process, I will re-engineer the floor to make that happen. Right? And we now have a group of people who have that mindset and are actually looking for opportunities to take that out. But you really have to be rigorous about this in a way that manufacturers talk about and they recognize the importance of in the end, but it's still not necessarily the thing they're obsessed about. And in many cases, they actually don't even know where their time is going, right? They don't have time and motion studies. They don't actually know where their labor costs are going. And if you don't know where your costs are going, you don't know how to optimize them. So the assembly part of this stuff, right? The printing is easy, especially with modern printers, right? I can send a different image to the printer. We put it on whatever we're putting it on, right? Largely hands-free. But at some point, stuff has to get put together, right? And that's done by humans mostly. Some of it can be done by robots, but not all of it. That's where the big part of the problem is. Right? People get caught up in pieces of software to do all kinds of clever automation, right? And they forget about this assembly part of the problem. And then when it's all done, I've got to do tracking and rework, right? Instead of having 10,000 items, and if I drop one and I send 9,999 to the customer, what's the customer going to do? Ask me to go back and make one more? Well, yeah, actually Home Depot might do that, right? But by and large, it's close enough. If the customer bought one and I lose it, that's the whole order, right? And now I've got 9,000 things going across my floor, each of which is going to a different customer. It's a different tracking requirement. Speed, oddly enough, is not always your friend. One of the common errors we have, and there's nothing we can do in our production process to eliminate this, is customers will call us. They'll want a phone number put on a product. Sorry, not call us. They'll go online. They want a phone number put on the product, and they enter 9 digits. We don't always control the customization interface, so we're not always in a position to validate what they've put in at the point of entry. And so we get an order which has a phone number that's obviously missing a digit. And we're at the point where from the time we strip an order to the time we're in carrier packaging ready to go with that product is about 6 minutes. If the customer doesn't call us in the next 15 seconds, we're going to have to remake the product. Or we're going to figure out some clever way to figure out what their phone number should have been, which we occasionally do. Right? That's not the mindset if I'm doing big production, right? There's time in there for a validation cycle that we just don't have in single piece production. So there's the what are the errors that I'm making, and then there are the what are the errors in the input I'm getting that I can't always control. And if I'm under an outside constraint that says I have to deliver whether I'm able to talk to the customer or not, the best I can do is produce and say, I'll send you a fixed one when you get back in touch with me. Or if you're selling on Amazon, you have to ship, whether you have the information or not. That gets a little entertaining. So in the mass production world, there's this list of things people know that aren't actually true, right? One is this idea that big batches are better. Another one is that long lead times are not only acceptable, but normative and unavoidable. And I don't want to wait 6 months for my product. There's a notion that transportation is cheap because so much product is moving that the transportation is well amortized. Transportation is not cheap, and I'll come back to that. I've sort of talked about this, I bought the big machine problem, right? A lot of the thinking that goes on, now, this is not universally true and it's changing rapidly, but a lot of the thinking that goes on is how do I maximize the utilization of this very expensive piece of equipment that I just bought, partly because I fell in love with the thing, I paid more for it than I should have, and now I got to justify my decision, right? When what I need to be thinking is how do I maximize customer value? The closer you get to the customer in deciding how to do that, the better you are able to do that. And there are lots of barriers between a large producer and the customer. And those barriers, people think distributors and middlemen reduce risk. Well, we don't. Right? Actually, distributors, in a weird sort of way, provide a funding solution for manufacturers. Right? They buy product from the manufacturers, they store it, and they hope like heck that it sells. Right? It's in some sense a financing exercise. But ultimately, if that product doesn't sell, the distributors often have the right to return it. Now what? Okay, transportation is not cheap. It's actually quite expensive because every transportation step, I'm moving product from one party to another party so that the second party can do something. Second party is going to touch the product. They've got to add cost to pay for whatever it is that they did, right? So they're going to add markup. And by and large, the markup they're going to add is 30% at every touch of the product, except for the last step, because the retailer typically wants to make half of what you pay at the point of retail. They want to make that as their part of the sale, rule of thumb. So if you send a product to a second party to be plated or finished, you're adding 30% to the cost of the product, not because of the cost of the plating, right, but because of the markup. This is sort of the failure of vertical integration in this particular example. Right? Most of the transportation steps have to do with inventory and distributors in the middle. These supply chains, as we've seen in the last 2 years, and this is no surprise to anybody who actually understood how they work, these supply chains are incredibly brittle things. And if we can get from where we are now to doing digital production in a more localized way, where these things are better integrated and they're happening local to the customer and they're not moving around to 15 different parties, our estimate is that we can get from 11 transportation steps for a part on average by the time it gets to the customer to somewhere around 6. And all by itself, right, that reduces the list price of the product that you see in the store by 3.7 times, because every transportation step is adding 30%, except for the last one. And if we then take out the 30% of products that are going unsold because nobody actually, that's another 1.4 reduction in peg price, right? Because we don't have to pay for those products. And when you add this up, this is a little better than a factor of 5. Do I think we're going to get to it tomorrow? No way. This will be a gradual transition. But I think we actually can go, we think we can get to single piece production. We can be producing what the customer wants, and we can do it reducing the price, which is kind of astonishing because everybody's been telling us for decades, make money making things one at a time. And with digital production, that's just not true anymore. So as we set up Buttonsmith, we sort of started with this notion right from the beginning that we were going to do things one at a time, and we were going to do them in the way the customer told us that they wanted them done. So we build absolutely everything that we do on demand. Actually, there's one product that's an exception to that, and I am desperately looking forward to the day we can do that one on demand. It's a no equipment to solve the problem sort of an issue. Right? And it means that for this one product, we carry finished inventory, and it makes me crazy. We by and large don't carry finished inventory. There's that one exception, right? Everything we do is flow oriented, not batch oriented. It's not that we're not doing high volume, right? It's that we're doing volume, which is a series of single pieces, right? And we don't want anything bottlenecking, right? Because then we've got a pile we've got to clear out that just wastes time. One of the things I've said, and it's one of the reasons in some cases we haven't always expanded our product capabilities quickly, is if I have a choice between buying a second printer or having somebody change the media on a roll printer, I'm going to buy the second printer because I can't afford to change the media every day. And that's a crazy mindset from a mass producer perspective, right? The mass producer is all concerned about amortizing the cost of the changeover. My goal is to get rid of it. We're a union shop. That's partly about who our customers are, but it's also partly a philosophy decision. Right? We actually believe that our people matter. One of the first rules we have, we laugh about it a little bit internally, but we're serious, is, step 1 is don't kill the company, and step 2 is don't hurt the employees. Right? We won't run solvent printers because they cause neurological damage over time. We've made the choice that we're not going to do that. We're a US made company, right? We're making money in this process doing it US made. You can't do that either, but nobody told us the time. We're set up as direct to customer because you can't inventory stuff that is individuated for each customer. It doesn't make sense. And that means there are all these stages in the middle that we don't have to pay for. And that the customer doesn't experience delay waiting for those intermediate steps to deal with their purchase. And because we started primarily as an Amazon Prime seller, one of the very early decisions we made was to focus on speed. And at the time, the way the rules worked for Amazon Prime was, you have a shipping cutoff, and your same-day ship obligation ends 1 hour before your shipping cutoff. So whatever comes over the wall at T minus 61 minutes has to be made and shipped that day. And we built an entire production facility to make that possible. And getting it down to 10 minutes per product wasn't that big a challenge. Getting it down to 8 minutes per product, that was a little more. Right now we're at 6 and we're at 3 labor minutes. Getting from 8 labor minutes to 3 labor minutes was brutal, right? And now we're pushing to do better, but that's where we are. That's well within the time frame in which you actually could make the product, right, and ship it same day, unless it comes in at 5:01, or when you're shutting down. So that's what we focused on doing. And in most cases, we actually produce faster than companies can find an already made product in inventory and ship it. I'm not talking about Amazon. They're extraordinary at doing this. They're at about 7 seconds, and that's really impressive. We're definitely not there. But most shippers aren't there. Most fulfillment houses aren't anywhere close to that. We did a lot of automation to do this because, of course, there's actual work that has to happen in this process, but a lot of it is rote work. We started at the customer and worked our way back. The very first thing we looked at automating was, how do we take what the customer handed us and turn it into something we can put on the floor and start production on with as little human effort as possible. And we're about 5 seconds of order validation per order, and we're done. And the only reason it's 5 is because 1 order in 10 has some error we actually have to go deal with. Most of them, you take a quick glance, the order's fine, you're done, you send it to production, you move on to the next order. And to work through all this and to make sure we understood which were the right problems to solve, we set up a prototype production floor. If you want to build software to do something new and you don't do that, you're throwing darts at the wall, and you can get lucky, but it's not what you'd call a robust business strategy. If you know about lean manufacturing, you're by this point hearing a lot of echoes of lean ideas in here. And that's right. We're pushing the lean notions kind of to the next step. I mean, lean now is, the original ideas are probably 70 years old, and there's some things we can do better, but they're still sound, right? They're very much like John Hennessy's work on quantifying computer architecture in some ways. The difference is we're relying much more heavily on automation, which when Toyota started working on the Toyota production system, part of the issue was they just didn't have the capital to do that early on. It's part of why they invented the lean system. Right? We're looking at things that are either high or low mix because the digital tooling can go either way. Right? People in the lean world talk about single piece flow, and they mean it. But when it actually comes time to deploy it in a real world, large scale manufacturer, the idea that they're going to work on single pieces is kind of unimaginable, right? So it becomes an ideal that you move progressively towards, but it often turns out to be something you never actually reach. In our case, we started doing single piece flow, and we were absolutely obsessive about maintaining that. And one of the big ideas in lean, and this is kind of the thing that when you stop and think about it, justifies a lot of the things that we're doing in mass production that are kind of problematic. They focused on reducing changeover time. Right? If you look at the lean literature, you'll see people talking about what they call single minute exchange of dies, right? It's about getting from one type of product to the next product as fast as possible, because every second you spend in the switchover, you're not producing value, right? And in the digital world, if you're careful about it, you often can get to 0 changeover times, right? So that's the secret sauce, right? Is the software automation and the fact that 0 changeover times qualitatively alter how we can think about the product mix. And you can't do that with the tools, with the methods, with the mindset that we've been applying to mass production. You need digital tooling to do it, and that's mostly not how production is being done in most of the world. I mean, we could talk about plenty of places that are further along in this. So what have we developed along the way to make this actually work? We do our order processing in about 5 seconds. That required a whole bunch of software support. We do design for automation upfront and customization. How is the customer going to customize the product or tune the product? That's part of our product design process, not just in the what's it going to look like sense, but in the how are we going to produce it sense. We're co-design on those things all the time. We've built a management engine for doing on-demand production of these kinds of commoditized products that lets us generate them very quickly. Along the way, we've done probably the best virtual product photography in the world, at least that we know about. 3 weeks from now, that'll be somebody else, because that's how this stuff works. And maybe the best listing management software in the world. And why are those two things important and hard? Your designer had insomnia, right? And they walked in this morning with 40 new designs because that was how they got themselves back to sleep. Those designs can go on 20 to 25 different product form factors that you have, each of which needs a new listing, each of which needs 5 product photographs, right? And you can see these numbers getting way bigger than a human can rationally manage. And by the way, that was just your designer, right? You have all these partners who are doing the same thing, and their designers couldn't sleep either, right? We're often doing hundreds of new listings in a matter of hours, and there's nobody else in the world who's doing that right now. For each of those listings, we've got to do product photographs. And where did those? Oh, and these are examples, right? So there was no per product photography that happened here, right? This was the design getting morphed over the product. It's a little bit of an unfortunate exchange of very similar kinds of products. And when you step back and look at all of this, the assumption that single piece production is expensive turns out not to be right. Suppose it actually were twice as expensive to make it. If you get the transportation steps down, the end price to the customer is still lower, right? And that's actually very hard to do in a mass production mindset, right? Getting rid of the things that are unsold because we don't make them if they're unsold is big, right? And it turns out it's not, it's 10 to 15% more. That you're doing something wrong from our point of view, at least, right? The first is, you think statistical quality control is a good idea. You're building these things, you have people touching them at lots of steps along the way. If these people have their eyes open, they should be doing quality control as the thing moves across their hands. What were they doing, right? Why do I now need some inspection station later to make sure that it all went well if my people are doing the right steps and actually thinking about their work as they're doing it? I mean, there's a question to be asked here, right? In our view, you're doing something wrong if things stack up, because that means that you've got an impedance mismatch between one stage of your production and the next stage. Fix the production process. Don't figure out how to build stacks of things. You're probably doing something wrong if you're tempted by job shop scheduling software, right? The reason we have job shop scheduling software is that we have big jobs and we have little jobs, and we have to find a mix in which our customers are satisfied and we don't stop using the equipment. Maybe the answer to that is not to have big jobs, right? When all the jobs are one piece, the job shop scheduling problem goes away. I saw some beautiful software yesterday to track and manage this kind of an issue. And the poor person I was talking to became very frustrated because we don't have this problem. And it's not that I don't want to track things. It's that my motivation for tracking things is very different than the problem the software was trying to solve. If you're looking at job shop scheduling, look at your production processes because something's wrong. Here's a big one. You're making a mistake if you make something before it's paid for. That's huge. I think there's a real possibility that we can get digital production to a negative cash conversion cycle, at which point the more you make, the more money you make, the more you're able to grow. We're not there yet. And I have to qualify that, right? Because there's an initial fill on parts and you're going to have to do that ahead of time. So we're not strictly in the way negative cash conversion is described, right? But that's possible here because the process is so fast and you don't have all of these artificial delays built into it. In deadline, and I guess I'm kind of back to the job shop thing, right? If my deadline isn't now, the right question is, why not? What am I doing that I can't produce these things, with the view that everything has to be done now? Now, if I'm doing furniture, yeah, there's a 3-day curing process on my finish that I have to do at the end, and I can't take that out, right? So it's not that there's any magic here that lets me declare things to be done before they're done, right? But conceptually, my goal should at least be, let me get the product into the curing stage, and then I'll have it sit for 3 days before I ship it. But in some sense, I'm done, right? I've got the shipping step left to do, right? But I'm not going to wait for another 1,000 units to be made before I'm going to talk about shipping. Even Alon can do this. I love picking on Alon because he's so bigger than life. In a sense, Tesla is collecting payment before they start producing. They're not collecting the whole cost of the car, right? But you do have to put in an initial amount to get your reservation done. And there's a psychology of commitment there. In some sense, they know you're going to pay before they actually make the car, right? The Model 3 right now takes 10 hours from the time the order goes in to the time the car is off of the production process. That's awe-inspiring. And it's one of the things about Tesla that I think is underappreciated in the media is how successful they've been at automating and tuning and reducing their production costs. It's really stunning. The full self-drive gets all the attention, right? But this is one of the big things that they've done, right? In a sense, they're doing local production, right? They're standing up production facilities nationally. It's not at the scale of your local shopping mall, but at least in principle, they could do 48-hour delivery on every vehicle they sell, made in that 48 hours and delivered by the time those 48 hours are over. They'd have to stand up a few more production facilities, but not very many. Wherever they can, they're using local suppliers, which eliminates or reduces their supply chain vulnerabilities, right? They're doing continuous improvement, right? They make changes on the vehicle continuously. There's no notion of a model year. Okay. I'm running out of time, so I want to do some of these selectively. I've already talked about the 9-digit problem. One of the things you'll find if you go to like a printing trade show is people will talk to you about keeping track of your ink costs. And I got to tell you, if you can find your ink costs in the production, you're doing really well. That's about the last thing you need to look at. I've talked about the cost of walking around, so maybe I don't need to come back to that. But here's one, right? And this is sort of about how do you think about product design, right? Why can't you buy pre-addressed wedding invitations at any sort of reasonable cost? A digital press could do that. The reason the digital press doesn't do that is you have to unfold the flaps to run them through the digital press, and unfolding the flaps takes a human, right? And the labor time makes the cost prohibitive. So why are the flaps folded? The flaps are folded because behind your distributor, there was an envelope converter, and the envelope converter has this practice of folding the flaps before they put them in the box. So when does the flap get folded? Turns out it's the very last step in the production of the envelope. They only need to turn it off and put them in a different size box, and then you can print individually addressed wedding invitations. Why isn't it being done? Because nobody's thought across the process chain to ask why this step is being done in this way and could it be done in a different way. I talked about the palette issue with ESCO. Sort of a related discussion with HP. At the time, we were looking at how do we print coroplast on two sides, and HP is saying, well, run it through the machine and bring it down or back around the front of the machine and turn it over and run it through on the back side. I'm like, I don't want to pay somebody to run around feeding things to machines. That's not value. What I want is a robot arm, and I'm going to run the first side through one machine, and I'm going to put a second machine at the output of the first machine, and I'm going to have a robot arm pick the coroplast off the first machine, turn it over, put it on the second machine, and we'll just do the whole thing linearly. And then we'll feed it into the cutter, right? This is the flow idea. I don't want to stack this stuff up and finish it later. I want to get it through and get it done. And this was a sort of an interesting conversation from the perspective of the HP people for two reasons. One, nobody had actually pointed out to them that this was possible. And the second, and this is sort of internal politics at work, this sort of thing never happened at IBM. There are bigger divisions that think they own the palletizing problem, right? These are the mid-sized printers, and they kind of like the idea that they would get to offer a capability that the grand printers don't offer, right? It's sort of an internal, ego battle about one division's products versus another. So the idea that they could do this is kind of fun. This last story, though, is worth telling. So when COVID hit, we actually were on top of it pretty early. We went into quarantine at the end of January. In that first year. And of course, in the state of Washington, businesses went through a mandatory shutdown. And we realized that we had the capability to do masks. By the time it was all done, we were consuming 85% of the output of one of the major US textile producers. We sold a lot of masks. Of course, Hanes decided to do that too. Levi's decided to do that too. And they started actually at about the same time that we did with their designs. And they did what they always do, right? They come up with a mask design and they send it to Honduras to have it manufactured. And 3 to 4 months later, the first cargo containers full of masks come back. Now, we did an initial mask design that was frankly pretty conservative. It was pretty conventional. And we started getting feedback from customers. The mask would be better if it did this. Could we get a filter pocket? Sure, we added a filter pocket. Could we find a way to make the masks adjustable so that they fit better? Yeah, we did adjustable masks. pretty much every adjustable mask that you see out there right now that's a cotton mask is a clone of our adjustable mask. Can we make masks that are sized for children? Sure, we can do that. And the reason we could do all of those things was we didn't have a huge commitment to fixed inventory that we had to worry about abandoning. By the time those products came back from Honduras for Hanes, we had done 4 design turns responding to the market. You can't do that if you're producing 1 million of them at a time and hoping the things will sell. It just doesn't work. And by the way, you also can't keep your long tail value. We have probably the most dog collar designs in simultaneous production of any company in the world. And because we do them one at a time, it costs us nothing to keep a slow moving design in stock, figuratively speaking, that is able to be made on demand. Turns out that's 10% of your revenue. And the reason nobody can tell you that is nobody's in a position to try it. But it actually matters. Okay, so putting this all together, and I probably need to stop pretty soon, Dennis, because we should respect people's time. So Buttonsmith has managed to grow about 85% a year for the last 7 years. We've done it mostly organically. I personally put some money into the business, but that up until now is the only outside investment we've taken. There have been years in which we've grown substantially more than that. We had a 500% year, and that's great on the one hand, and it's also the kind of growth that can kill your company if you're not prepared for it. We continue to have a per capita revenue that's higher than Microsoft. That's crazy. We're a manufacturer, not a software producer. Average units per order. I mean, I talk about us doing single piece production, right? In the 600,000 orders that we had before we started making COVID masks, the average order was 1.04 things. That's as close to one piece production as you really get in the real world. There's always somebody who orders 2 of something, right? So you never get to 1. I've talked about the numbers on our production times. This is producing something that we've potentially never seen before. I mean, we've seen dog collars before, but we don't know how this dog collar is going to be done. And if I take out the errors that arise because the customer handed us bad data, which is not something we're in a position really to fix most of the time, our rework is substantially below 0.5%, actually closer to 0.03% the last time I measured it, which is crazy. The mass producers often have rework rates much higher than that. And partly it's because we're looking at everything as it goes by. Okay, so let me open up to questions. And also for anybody who's at Stanford who I can't see, maybe in the classroom, if I don't manage to get to questions, feel free to reach out. We've got a mailing address we've set up, and send your questions, and I'll do my best to get them answered for you. So questions about this. Has been a long talk, and I apologize, but.
Well, I guess I'm going to be first person here and just ask that we use no names because that keeps the video clean. And then I have a question, John. Are you going to be in the business of making plants?
Of making plants?
Yes, manufacturing facilities.
In an indirect sense, yes. Ultimately, I think we would prefer not to be in the production business at all, right? Our goal is to do the software issues around the production, because frankly, there are people who know a lot more about production than we do. That said, this is not the kind of production that they have an enormous amount of experience with, right? And that issue of how do we get to the right combination of hardware modularity and software modularity, process modularity, that's new territory. And we're going to have to prove out those techniques, and then we're going to have to make them available to producers. For reasons I've articulated, that's going to be a slow process. There's going to be resistance to change. And not because people are resistant, but because it's actually really hard, both conceptually and financially. Hopefully, we will see new people coming into this marketplace who are willing to try something different. But I think, frankly, we're going to have to stand up more production facilities while that's happening. And the more successful we are at that, the more it's going to be difficult to sell what we're doing, because we'll end up competing with our customers, and then we'll have to back off. We have to navigate that process one way or another. How it's going to play out is very hard to know in advance.
Okay.
What kinds of products are you talking about? You're thinking about making other than buttons, business cards, and dog collars?
Good question. So we started in what might be characterized as sort of promotional kinds of products because it was the low-hanging point of entry into this space. Right? It's relatively speaking pretty easy to do. It only took us 6 years to get all of that working. But now we've got all this infrastructure working. And actually, I was talking yesterday with several different companies who are in one form or another of 3D production or specialty production. And we will move into those spaces. HP has done some really interesting work in reducing the cost of plastic printing, 3D printing. Now, there's a whole process that their stuff has to go through to be something that you're going to hand to a customer. But it's the cheapest by far on a cost per unit basis of anything that we've seen. Of course, it's a $250,000 printer, so you're not going to buy one for your basement. But that's a whole new class of products that we can optimize for customers according to customer need. And curiously, it's a family of opportunities where now I have all these people who bought this $250,000 printer and they need to pay for it. So we're definitely moving in that direction, but I think that that 3D is the next place that we're going. Do you mean multiple process steps? Yeah. So one of the questions that got asked the very first year we went to what's now Printing United, they run panels, right? And people ask questions. And one person in the audience said, "Hey, I'm opening up a new print shop. How do I remain competitive with the print shop down the street?" And the answer that came back from the panel, I thought was insightful. The person on the panel said, do something that involves at least 2 steps, because the likelihood that you and your competitor can do the same 2 steps is actually pretty low. The more steps you put in, the more true that is, right? And so now you're differentiated because you can do something that they can't, and probably vice versa, right? The HP products actually have this property because of the extra steps that they have to do. So we are very, very definitely moving from doing things that I think you could characterize as 2D, maybe 2.5D in some cases, into 3D. I don't see us doing that this year. I think our big challenge this year is dealing with some of the soft materials and dealing with automation around that, but we're definitely going there.
Well, but your products are all things that are needed rapidly to be worth it to the customer. I'm trying to think of high value products that need to be available quickly. And the only thing I can come up with is things involving dentistry.
There's actually a huge business there, it turns out.
Yeah, I know. In fact, the largest just-in-time manufacturer I know of is Invisalign, which makes those 3D.
Yeah, and they have a really interesting process behind it. And I apologize for framing it this way, there's a generational thing going on here, right? My father can't understand why getting things in 2 days matters, right? He just doesn't feel that sense of urgency, right? But Amazon has trained a huge customer base to think that 2 days is the criteria for success. Whether they actually need it in 2 days or not is irrelevant. They think they need it in 2 days. And that makes it a customer requirement. And for a long time, it was why people bought from Amazon. Now, I think Amazon is putting that process at risk right now.
Mm-hmm.
Right. If you can get your car in 2 days, will that change who you buy your car from? And the evidence would suggest that the quick turnaround that Tesla's able to produce actually matters.
Well, I mean, so here's an example. A new phone comes out and it doesn't have accessories until 3 months after it's been shipped. The MacBook Pro 14-inch came out, you couldn't get a case for 3 months. You could get the machine, but not the case. So I'm sure there are other examples of cases where rapid manufacturing would have a big market, but I'm not coming up with the products quite yet.
How about pastries in a restaurant?
Pastries.
Or,
you know that people are doing custom pancake printing? Did you know that?
Birthday cakes.
Here's an example that's just a little, it's adjacent to the one that you get with the phones, right? Why can't you get a PlayStation right now?
Good question.
Right? Are there people who would buy that if it could be produced locally? You bet. I mean, right now, the gray market, if you will, in those devices, people are paying 4 or 5 times the list price of the devices to get them now. And that's a pretty good calibration of the perception of urgency. And as to the cases and things like that, so what's the issue with the cases? Why does it take 3 months? I mean, the device comes out, right? My designer sits down and designs a case. That's not a multi-month process. That's a day or 2. Well, why does it take 3 months? Because I have to do the mass production and fill the pipeline. So my answer to that is get rid of the pipeline.
So, John, if that's the case, what sort of a material supply line do you have for the local small volume special device manufacturing?
It's a great question, and we were actually talking to people at HP about this just yesterday. So I think right now our material supply, at least, mostly takes the form of parts. But going forward, I think as we integrate vertically, more and more, that will drive down towards raw materials. When I look at my physical inventory space for all the parts we have, right, I've got 2 vendors who account for 60% of my physical inventory volume. The reason they account for 60% of my physical inventory volume is they're unpredictable, and I have to buffer to deal with their unpredictability. And there's one of them that I would give several teeth to remove from my supply chain because they're so unpredictable. And HP may have just given me a way to do it. And the cool part about that is that the HP device, it's not as fast as injection molding. No way, right? But I don't need 1 million parts a day. I need the parts I'm going to consume in the next 24 hours if I'm taking that approach, right? And that's a different problem statement. Maybe I do it a week at a time, right? But I don't have the same carrying costs, right? And the input material at that point becomes the filament or the deposition powder or whatever it turns out to be. And it's not that I'm eager to move away from these part suppliers. They often have really valuable expertise that I don't have. Could learn, maybe, but there's 100,000 things that I could usefully learn next. I got to make choices. When I have a supplier in the way, right, I'm going to try to vertically integrate them out of the picture because they're in my way. So I think as that happens progressively, we're going to see a move towards closer and closer to raw materials.
Well, do you think, John, that you've just opened up the can of worms here and have maybe launched a change in the total way in which we perceive manufacturing?
Well, I think we'll know in 10 years, but I hope so.
I hope we learn it sooner than that. 10 years is a long way out these days. But
Dennis, for you, we'll make it happen faster.
Okay, that's good. Can you get it finished in 5?
We'll do our best.
How about 2 days?
I don't know. There's a learning curve here. There are things that we don't know. Worse, there are things that we don't know that we don't know. And we're going to have to work our way through it, right? That's why there is this prototyping facility, and we're going to hit roadblocks. We're going to hit surprises. But I can speculate with some confidence that this year will not be one of the 85% years. We'll do a good bit better than that this year.
Okay.
And I'm feeling a little cautious about saying how we're going to do that right now. It's because of a new product line that we're launching that matters and has time sensitivity.
Okay, well, we're running up out of time. Is there any other question? Oh, okay. Well, John, thank you very much. It was, I think of the 380 talks that I've had something to do with, which were a few, this is one of the more significant. I think in 5 years' time, we'll go back and look at it and we'll say, that was the beginning. So I think you've hit on a really very significant point, and I really appreciate you giving us the opportunity to hear what you have to say.
You are gracious as always, and I still owe you that modular robotics talk that I promised.
Oh, that's fine. That we'll set you up on that. And but thank you for this. This is at least given me a great deal to think about, and I think it's really good. I do want to point out that you your choice of the name Buttonsmith makes sense. On the one end, you push a button to get something done. And of course, Smith makes things. So, how you picked that name, I don't know.
It's funny. It did make sense when we started. And of course, you can do a retcon, right? And tell the story like you told now. But explaining to investors that you're not actually a manufacturer, which is a requirement if you want them to invest, gets a little tricky when your name is Buttonsmith. And so what I think is actually going to happen is that we will push into a new name that's not bound in some people's heads to manufacturing. And then we'll look at some restructuring so that it's easier to see that we're a software company. It's a perception problem, but perception is real. It's important.
It's true. Anyhow, thank you very much. And we'll certainly be watching what goes on here. Thank you.
Take care. Thank you all.
Bye-bye.